All right, so are you ready? We're going deep today into Concepts of Physics by H.C. Verma.
Oh, yeah. I've heard great things about this one.
Yeah, you're prepping for this huge physics exam,
Oh, yeah.
maybe something like the IITJEE.
Okay, yeah.
You really want to know why everyone's talking about this book?
Absolutely, I do.
It's not just hype, let me tell you.
Okay.
This two-volume set, it's really famous for building like this rock-solid physics understanding.
Yeah, I've heard that.
It takes you all the way from the fundamentals
Huh.
to like mind-blowing modern physics.
I'm excited.
I think it's going to be good. So let's just crack open volume 1, right? What do we have?
So volume 1 is all about like laying the groundwork,
Yeah.
Verma starts with the basics, like how physicists measure things,
Okay.
all the different units they use.
Yeah.
It might seem simple,
Right.
but trust me, it's really crucial to get these fundamentals down.
Yeah. It's like learning the alphabet before you write a novel, right?
Precisely.
Yeah.
And then from there, we jump into kinematics, the study of motion.
Speed, velocity, acceleration, all those things.
Right.
That describe how objects move. Verma, he's got this knack for explaining it.
Yeah, I struggled with those equations of motion, like way back when.
Oh, yeah.
How does he make them easier?
He uses like real-world examples and really relatable scenarios.
Okay.
So, for example, imagine you're trying to figure out how long it takes for like a ball to fall from a certain height.
Uh-huh.
Verma will walk you through the whole process, break down the problem step by step,
Okay.
show you how those equations apply to the real world.
So it's not just memorizing formulas, it's
Yeah.
understanding how they work.
Exactly. And that's where his problem-solving approach really shines.
Yeah.
He doesn't just throw equations at you.
Uh-huh.
He teaches you how to think like a physicist,
Okay.
analyze problems, and apply those equations to actually solve them.
That's so helpful.
Yeah.
Especially for an exam like the IITGE.
Right.
They're known for challenging problem-solving questions.
Absolutely.
But he doesn't stop at motion, does he? No, he doesn't.
He delves into like the laws that govern the universe.
Yeah.
Newton's laws.
So Newton's laws are the bedrock of classical physics.
Okay.
And Verma explains them brilliantly.
Uh-huh.
So he breaks down these concepts like inertia,
Oh.
that tendency of an object to resist changes in its motion,
Right.
force and friction, making them easy to understand and apply.
So if I trip and stumble,
Yeah,
that's inertia trying to keep me moving in a straight line.
that's a great way to put it.
Okay.
Yeah, and the force of friction between your feet and the ground is what eventually brings you to a stop.
Okay.
Verma would even explain how different surfaces have different frictional forces,
Mm-hmm.
which is why it's so much easier to slip on ice than concrete.
It's amazing how physics is at play
Yeah,
in even the simplest actions.
absolutely.
And then we move on to work, energy, and power,
Yeah.
concepts that always seemed a bit abstract to me.
Verma has this gift for turning the abstract into something concrete.
Okay.
So let's say you're pushing a box up a ramp.
Okay.
Verma would explain that the work you're doing is directly related to the force you apply
Okay.
and the distance you push the box. He'd connect that to the energy you're expending and how quickly you're doing it, which is power.
So he takes these concepts out of the textbook,
Exactly.
in our lives.
Exactly. He might even connect it to something like lifting weights at the gym.
Okay.
He'd show you how the work you do lifting those weights
Uh-huh.
is stored as potential energy and how the power you generate depends on how quickly you lift them.
Okay.
It's all about making those connections,
Got it.
helping you see how the physics underlies it.
This is where I get really excited. Rotational motion and gravitation.
Oh, yeah.
Spinning tops, planets, orbiting stars. It's just mind-boggling.
It is.
How does he make those concepts accessible?
Imagine a figure skater spinning.
Okay.
As they pull their arms and they spin faster.
Right.
That's angular momentum in action.
Okay.
Verma explains it beautifully,
Okay.
and then there's torque. The rotational force that causes things to spin.
Okay.
He might use the example of loosening a bolt with a wrench
Okay.
to illustrate how the length of the wrench affects the amount of torque.
So it's like physics is hidden everywhere.
Exactly.
Even in a simple tool like a wrench.
Absolutely.
Yeah.
And then when it comes to gravitation,
Okay.
Verma starts with Newton's law of gravitation,
Mhm.
explaining how objects attract each other.
Right.
Remember that apple that supposedly fell on Newton's head?
Yeah.
That's gravity
Okay.
in action. Verma would then connect that to the motion of planets and satellites,
Okay.
showing how that same force that causes an apple to fall also keeps the moon orbiting the Earth.
It's incredible how one law can govern
Yeah,
falling apples to orbiting planets.
it's true.
But Volume 1 doesn't stop there, does it?
It does not.
It delves into the properties of matter itself.
That's right. Verma covers everything from the elasticity of solids to the flow of fluids.
Wow.
You'll learn about concepts like viscosity, which explains why honey drips slowly,
Oh, yeah.
compared to water,
Uh-huh.
and surface tension, which allows insects to walk on water.
So it's like he's giving us new lenses to see the world through.
Absolutely.
Yeah.
And then there's Bernoulli's principle,
Okay.
which can seem a bit tricky, but Verma makes it clear.
Uh-huh.
This is what explains how airplanes fly
Okay.
and why those cool water jets work.
So if I'm understanding this right, the shape of an airplane's wing creates this difference in air pressure
Yeah,
above and below the wing, which generates lift and allows the plane to just soar
through the air.
through the air?
Verma would explain all of that,
Wow.
connecting the concept to these real-world examples,
Uh-huh.
helping you see how physics is at work all around us.
And that's just the first volume.
I know, it's amazing.
We have so much more to explore.
We're just getting started. Verma has a lot more in store for us in Volume 2,
Okay.
where we're going to delve into even more fascinating aspects of the physical world.
Awesome. Let's take a break and come back for part 2.
This is good.
Okay, so we've laid some pretty solid groundwork with Volume 1, right?
Yeah,
We've explored the fundamentals of motion forces.
right.
We even delved into properties of matter.
Absolutely.
But I have a feeling things are about to get even more electrifying with Volume 2.
You're absolutely right.
Okay.
Volume 2 kicks off with electrostatics,
Okay.
the study of charges at rest.
Ooh, those static shocks you get on a dry winter day?
Yeah,
That's electrostatics in action.
that's electrostatics for you.
Yeah, so how does Verma unravel these mysteries of stationary charges?
Well, he starts with Coulomb's law,
Okay.
which describes the forces between electric charges.
Okay.
Think of it like magnets. You know,
Okay.
opposite charges attract, like charges repel.
So if I rub a balloon on my hair, it picks up a static charge.
Yeah,
And it can stick to a wall because the charges are attracted.
exactly. Verma would explain how rubbing the balloon transfers electrons,
No.
giving it a net charge.
Yeah.
And then he'd explain how that charged balloon interacts with the wall, creating that static cling.
So it's not magic, it's physics.
It's all physics.
Awesome. But we don't stay static for long, do we?
We do not.
We move into current electricity.
You got it. Charges on the move,
Oh.
flowing through wires, creating currents.
Now things are getting interesting.
Now it gets really good, especially if you're thinking about the IITJEE.
How so?
Well, think about all the circuits and electrical devices we use every day.
Right.
Understanding how current electricity works is crucial for designing and analyzing those circuits.
Okay.
Verma dives into all of this, explaining concepts like resistance,
Okay.
which hinders the flow of charge,
Uh-huh.
and Ohm's law, which describes the relationship between voltage current and resistance.
So resistance is like the friction
Yeah,
that slows down the flow of charges in a wire.
that's a great analogy.
Okay.
Just like different surfaces have different amounts of friction,
Yeah.
different materials have different resistances.
Uh-huh.
Verma would explain how the properties of a material affect its resistance and how that resistance affects the flow of current in a circuit.
So if I'm trying to design a circuit
Yeah.
for, let's say, a light bulb,
Okay.
I need to understand how resistance affects the amount of current flowing through that bulb.
Precisely.
Yeah.
And that's where Verma's problem-solving approach comes in handy again.
Yeah.
He'd teach you how to analyze circuits,
Okay.
how to calculate the current and voltage at different points,
Uh-huh.
and how to use those calculations to design circuits that meet specific requirements.
That's super helpful.
Yeah, it's like you're building your electrical engineering skills
Right.
right alongside your understanding of the physics.
But there's another force at play here, isn't there?
Oh, yeah.
Magnetism.
This is cool.
I've always been fascinated by magnets,
Yeah.
how they have this invisible power.
It's fascinating how magnetism and electricity are actually two sides of the same coin.
Okay.
They're deeply intertwined.
Uh-huh.
Moving electric charges create magnetic fields, and changing magnetic fields can create electric currents.
Wow.
It's this beautiful dance.
Mind-blowing.
Yeah.
So how does Verma approach this connection?
Well, he starts by explaining the concept of magnetic fields,
Okay.
those invisible regions of influence around magnets and moving charges.
Okay.
Remember those iron filings you sprinkled around a magnet in school
Yeah.
and how they form those cool patterns?
Yeah.
Those patterns represent the magnetic field lines.
Oh, okay.
Verma would explain how those field lines work
Uh-huh.
and how they relate to the strength and direction of the magnetic field.
So it's like a visual representation of
Exactly.
the invisible forces at play.
Yes. And from there, He delves into some really cool applications like solenoids and toroids.
Okay.
A solenoid is basically a coil of wire
Okay.
that acts like a magnet when current flows through it.
Uh-huh.
You'll find solenoids in all sorts of devices from doorbells to speakers.
Okay.
And a toroid is like a donut-shaped solenoid.
Okay.
It's used in lots of electronic devices like transformers.
Now it's all coming back to me.
Yeah.
But the connection between electricity and magnetism goes even deeper, right?
You're exactly right.
There's that whole concept of electromagnetic induction.
This is where things get really interesting.
Okay.
Verma explains Faraday's law,
Okay.
which tells us how a changing magnetic field can create an electric current.
Okay.
And then there's Lenz's law, which tells us the direction of that induced current.
Okay.
These laws are fundamental to understanding how generators work,
Okay.
which convert mechanical energy into electrical energy. Think of those giant turbines in power plants.
So it's like a dance between electricity and magnetism.
Exactly.
One can induce the other.
Right.
And these laws aren't just theoretical, right?
Is it not?
They have real-world applications that are crucial for powering our modern world.
Absolutely. Think about transformers,
Okay.
which are used to step up or step down voltages in power lines,
Right.
or generators, which we already talked about. They all rely on these principles of electromagnetic induction
Okay.
that Verma explains so clearly.
Wow. It's amazing to see how these fundamental laws underpin so much of our modern technology.
I know, it's pretty cool.
But Volume 2 doesn't stop there, does it?
No, it does not.
We've got alternating current to tackle next, AC.
Yeah.
What exactly is coming out of those wall sockets?
Good question. Verma demystifies AC circuits,
Okay.
which involve currents that constantly change direction. He
Uh-huh.
explains concepts like impedance,
Okay.
which is like resistance, but for AC circuits,
Okay.
and resonance,
Okay.
which occurs when a circuit oscillates at its natural frequency.
So if I'm understanding this correctly, the electricity flowing through our homes
Yeah,
is constantly changing direction.
it is.
And that's why it's called alternating currents.
That's exactly why.
And these concepts of impedance and resonance, they help us understand how AC circuits behave
Exactly.
and how to design them effectively.
Verma would walk you through all of that, connecting it to real-world applications, like how AC circuits are used in everything from household appliances
Right.
to industrial machinery.
Okay.
He'd even explain how those concepts relate to the electricity grid that powers our cities.
It's like he's opening up a whole new world of electrical wonders.
It is.
But wait, there's more.
There is.
We can't forget about optics,
Of course not.
the study of light.
Optics is definitely captivating.
I've always been fascinated by how light behaves,
Yes.
how it bends, reflects, and creates those amazing colors.
And Verma does a great job of exploring it. He covers all the basics.
Yeah, okay.
Reflection, refraction, diffraction,
What a diffraction, what's that?
and even polarization. He'll explain how light interacts with different materials,
Okay.
how it bends when it passes from one medium to another,
Uh-huh.
and how we can manipulate light to create all sorts of amazing effects.
Okay, so diffraction.
Yeah.
Sounds kind of like deflection.
Think about what happens when waves encounter an obstacle.
Okay.
They bend around it. That's diffraction. And it happens with light, too.
It's one of the reasons why you see those shimmering patterns
Yeah,
on a CD or DVD.
exactly. Verma would explain how those patterns are created by the diffraction of light waves
Okay.
as they interact with the tiny grooves on the disk's surface.
Okay, so diffraction is like light bending around corners,
Yeah,
and it creates those cool iridescent patterns we see on certain objects.
that's a great way to put it.
Okay, so how does Verma approach all these different aspects of light?
He uses both ray optics, which treats light as straight line,
Okay.
and wave optics, which considers the wave nature of light.
Okay.
This dual approach helps to explain a wide range of phenomena,
Cool.
from how lenses and mirrors work
Uh-huh.
to the captivating effects of interference and diffraction.
Okay.
He'll connect it to practical applications like how lenses are used in cameras and telescopes
Yeah.
to focus light
Right.
and create images.
So if I'm thinking about how a prism splits white light into a rainbow, that's optics at play, right?
That's optics in action. And Verma would dive into all of that,
Okay.
explaining how different wavelengths of light are refracted by different amounts, causing them to separate
Uh-huh.
and create that beautiful spectrum of colors
Okay.
we see in a rainbow.
Yeah.
He'd even connect it to the way our eyes perceive color
Okay.
based on the different wavelengths of light that enter them.
It's incredible to think about how much physics goes into something
Yeah.
as simple as seeing.
Yeah.
But we're not done yet.
We are not.
We're about to enter the realm of modern physics,
This is where it gets really wild.
where things get really strange and counterintuitive.
Absolutely.
Okay, so we've journeyed through those foundational principles of classical physics,
Yes, we have.
explored that electrifying world of charges and currents, even delved into that captivating realm of optics.
Absolutely.
But now we're stepping into a whole new dimension.
Okay, modern physics.
Modern physics. This is where we challenge all those everyday assumptions about how the world works. It sounds like we're about to enter a science fiction novel.
A little bit.
Where do we even begin with these mind-boggling concepts?
Well, we start with quantum mechanics,
Okay.
which revolutionized our understanding of the microscopic world.
Okay.
So imagine this, you're shining a light on a metal plate,
Okay.
and suddenly electrons start popping out.
Uh-huh.
That's the photoelectric effect.
And that can't be explained by classical physics.
Nope, it cannot.
Well,
Verma would explain how this phenomenon led to the development of quantum theory,
oh, okay.
which proposes that energy exists in these discrete packets called quanta.
So it's like energy comes in tiny bundles.
Yes.
Not this continuous flow. That's pretty radical.
It is.
Yeah.
And I remember you were talking about different atomic models before the break.
Yes.
How does Verma tackle that?
Yeah.
He takes us on this historical journey
Okay.
through the evolution of the atomic models.
Yeah.
Starting with that early plum pudding model,
Okay.
where electrons were thought to be embedded in this positively charged sphere,
Yeah.
like raisins in a pudding.
Okay. So that's the plum pudding model.
Yes. Then we move on to the Bohr model,
Okay.
where electrons orbit the nucleus
Mm-hmm.
in these specific energy levels,
Right.
like planets around the sun.
Right.
Finally, we arrive at the modern quantum mechanical model,
Okay.
where electrons are described by probability clouds.
Their location and momentum governed by these principles of wave-particle duality.
Yeah, it's a lot.
It's like trying to pin down a tiny, fast-moving particle that just refuses to stay in one place.
Exactly. It's no wonder those early physicists had such a hard time figuring it out.
But through careful experimentation,
Yeah.
brilliant insights,
Lots of trial and error.
they piece together this puzzle of the atom.
Right.
And Verma does such a good job at presenting this fascinating story
He does.
in a way that's both engaging and understandable.
Absolutely. Now, this is where we get into the realm of nuclear power plants and atomic bombs, right?
Right. This is fascinating.
Yeah.
But also a bit daunting to think about that immense power locked within the atom.
Nuclear physics is indeed a powerful field, and Verma explores it with both scientific rigor
Huh?
and a sense of responsibility.
Okay.
He explains the concepts of radioactivity,
Okay.
where unstable nuclei spontaneously emit particles or energy,
Right.
and then he delves into the processes of nuclear fission and fusion,
Okay.
which release tremendous amounts of energy.
It's amazing how something so small
I know.
can contain so much energy.
It really is.
It's like a tiny powerhouse waiting to be unleashed.
And that's precisely why understanding nuclear physics is so important.
Yeah.
It has such profound implications
Huh?
for energy production, medicine, even national security.
It's a reminder that physics isn't just about equations and theories.
Right.
It's about how we apply our knowledge and the impact it has on the world.
Exactly.
But wait, we're not quite done yet, are we?
Not quite.
There's one more area to cover: semiconductors and electronics.
Yeah. This is where we connect modern physics to the devices that power our modern lives.
Okay.
Verma introduces the world of semiconductors, materials that lie somewhere between conductors and insulators.
Okay.
He explains how the unique properties of semiconductors allow us to control the flow of electrons,
Right.
creating the building blocks of modern electronics.
Okay.
Diodes, transistors, integrated circuits.
So those tiny components in my smartphone,
Yeah.
computer, all my other gadgets,
Uh-huh.
they're all based on these principles of semiconductor physics.
Precisely. Verma gives us this glimpse into how these tiny devices manipulate the flow of electrons
Okay.
to create everything from amplifiers and oscillators
Wow.
to logic gates and memory chips.
It's mind-boggling to think that our digital world, with all its complexity and interconnectedness,
Right.
is built upon these fundamental principles of physics.
It all comes back to physics.
It's like this bridge between the microscopic world of atoms
Mhm.
and the macroscopic world of technology,
Yeah.
all made possible by these insights of modern physics.
Yep.
We've covered so much ground in this deep dive,
I know it's a lot.
from the basic laws of motion to the complexities of modern physics and electronics.
Right.
What really stands out to you about Verma's approach throughout these two volumes?
What's really remarkable is how Verma consistently emphasizes understanding over rote memorization.
Right.
He wants you to not just learn the formulas,
Yeah.
but to really grasp the concepts behind them.
Okay.
He encourages you to think critically,
Mm.
to question assumptions, and to apply what you've learned to real-world situations.
It's like he's not just teaching physics,
Right.
he's teaching you how to think like a physicist.
Absolutely. And for you listening out there, getting ready for that big exam,
Right.
that's exactly what you need.
Okay.
Verma's not just prepping you to solve problems on a test.
Huh.
He's equipping you with the tools to become a problem solver in life.
And he does it all with such clarity and precision.
He does.
His explanations are concise yet thorough.
Mhm.
He uses these real-world examples and analogies
Yeah.
that make even the most complex concepts accessible. He doesn't just throw equations at you. He breaks them down,
Right.
explains what they mean,
Yeah.
and shows you how to use them. It's like having a patient and knowledgeable guide,
Yeah, like a physics tutor.
leading you through that intricate landscape of physics.
Exactly.
He really has a gift for making the complex seem clear,
Yes.
the abstract seem concrete.
Absolutely. Whether you're a student gearing up for a challenging exam
Mm-hmm.
or just someone with a curious mind,
Right.
eager to explore those wonders of the physical world,
Yeah,
Concepts of Physics is an invaluable resource.
it really is. So for anyone out there who's feeling a little intimidated by physics,
Yeah.
I'd say give H.C. Verma a chance. He might just change your perspective
He might.
and spark a lifelong love for this incredible field.
That would be amazing.
Yeah.
So knowing how much physics governs our world,
Yes.
from the smallest atoms to the vast expanse of space,
Mhm.
what area of physics are you most curious to explore further?
What a great question to ponder. Keep exploring, keep questioning, and keep that curiosity alive. The world of physics is waiting to be discovered.